In this video, we're going to continue to look at entropy, and we're going to start with looking at the entropy change when we melt water. So we said in a previous video that the entropy of the universe is equal to the entropy of our system plus surroundings, since everything makes up the universe. And a process is spontaneous if the entropy of the universe is positive. So we're looking at water freezing at low temperature, which we know is spontaneous because the entropy of the universe is positive. And at high temperature, we know water does not freeze at high temperature. And if we look at the charts, that's because the entropy of the universe is negative. The entropy of the universe actually becomes more ordered. Let's try to understand why this is. Let's look at the entropy of the system. The change in the system going from liquid to solid at low temperature and at high temperature. What you should notice is that there is no difference between low temperature and high temperature if we talk about the system, that is the water. No matter what temperature you're at, the entropy change from going from a liquid to a solid will always be the same for the system. It will always be the same for the water. When you become a solid, you become more ordered, so your entropy decreases. What is the big difference, though, is the entropy change in the surroundings. When we freeze water, we're releasing heat out to the surroundings, and that's causing the surroundings to be more disordered, to increase in entropy. We said that this change in entropy is dependent on the temperature. So at lower temperatures, you see a bigger change in entropy. And at a certain temperature, that is 32 degrees Fahrenheit or 0 degrees Celsius, the surroundings, the change in entropy in the surroundings, is greater than the negative change in the system, which makes our overall change in entropy in the universe positive. That is, we have increased the disorder of the universe by freezing water at low temperatures. And that is why water freezes at low temperatures and not high temperatures. It all has to do with entropy. Now, when we talk about spontaneous processes, we don't really talk about entropy of the universe because we couldn't possibly look at the entire universe. Rather, scientists will talk about Gibbs free energy, or delta G, or just G. And G is the maximum amount of work that a system can do, or it's just called the chemical potential because it's basically like how much energy is in this system. The equation for delta G, or Gibbs, is delta G equals delta H minus T delta S. And you see these deltas, the change in Gibbs free energy, the change in enthalpy, which remember is heat, the change in entropy, which is disorder. That's because we can never actually measure heat, we can't measure disorder, we can't measure energy, we can only measure the change in these things. And one last thing to look at this equation is that we have T times delta S. And that's because we said that delta S changes based on the temperature. And so there's some math that went on that we don't have to go over that gave us this equation, but basically it is just temperature times delta S. The lower the temperature, then the less effect delta S will have. The bigger the temperature, the more effect delta S will have. And temperature here is either going to be in Celsius, or it's always going to be in Kelvin unless otherwise stated. Temperature is always going to be in Kelvin. That's because Kelvin, the lowest temperature you can go to is absolute zero, so Kelvin's always positive. That's why we use Kelvin here, because that negative sign is very important. So delta G is what we use to determine something spontaneous. And a process is spontaneous if delta G is a negative value. So that means that delta S universe is positive if delta G is negative, right? So delta G is negative, it's spontaneous. If it's zero, equilibrium. If it's positive, non-spontaneous. And just by knowing whether delta H and delta S are positive or negative, we can say some things about the spontaneous nature of that process. So let's say we're looking at a process and we know delta H is negative. It's exothermic. It releases heat. Delta S is positive. We increase the entropy by doing this. Well, at low temperature, if T is low, then minus T delta S will always be a minus. Well, delta H is a minus. Minus, minus. If you add two minuses together, you'll always get a minus. So no matter what temperature, if delta H is negative and delta S is positive, you will get a negative number, spontaneous. What if your process is endothermic? It absorbs heat, and then delta S is negative, so you create order. Well, this is the opposite. Since you're absorbing heat and creating order, this process would never be spontaneous because delta H is positive, and if delta S is negative, negative times a negative is a positive. Positive minus a positive, positive and a positive added together will always be a positive. What gets tricky is when they're the same sign. So if delta H and delta S are both negative, then at low temperatures you're spontaneous. That's because this term minus T delta S would be actually a positive, because negative here multiplied by negative delta S is a positive number. Well, if T is low, that means this whole term minus T delta S will be small, and so delta H, which is negative, will determine that delta G is negative. So this is what's happening with water. The minus minus case is what's happening with water. What if it's plus plus though? Here we're spontaneous at high temperatures because delta H is positive. Remember, we want delta G to be negative. So the only way that delta G equals delta H minus T delta S will be negative is if this minus T delta S term is bigger than this delta H term. And we can look at this in terms of K and Q. And so when Q is less than K, we're going to go from products to reactants. Reactants to products. Delta G will be negative there. If Q is greater than K, we're going from products to reactants. Here, delta G will be negative in that process because both of these processes are spontaneous. That's it for this video. I will see you in the next video.